Hey everyone, welcome back to my channel. We're gonna cover today how to build a movie information agent. So this agent can be used to collect information or get information about any movie or TV series. So let me try this. Tell me about the different great movies. So you can ask it information and it's gonna return back quite fast about different movies. So let me now ask what is the rating of the 2010 movie? So basically there were movies for TrueGrid in 2 of the years. So it's gonna then poll and give me the rating for here. Now let me tell me about the anime Demon Slayer. So you can ask about anything and returns back quite fast with the answer. So we're gonna look at how we build something like this. The key thing that's kind of differentiator here is that we're gonna use a bunch of APIs here to get information, and then we'll use those informations and combine that with memory to build a chat agent. So that's the flow that I want to cover here. The APIs that we're gonna use are OMDb API. So this is a open movie database with a lot of information on different movie series, release date, directors, ratings and stuff. So we'll use that to be the source of information here, and we're going to use Groq for running this chat agent because it's super fast and free to use. So that allows us to build this. So I want to kind of structure this by first going through the design of the agent, and then we'll look at the code associated with it. So this movie agent here, they are comprised of a few things. A standard agent actually has 3 or 4 main components. One is tools, the other is memory, third is sort of planning, which we're not really doing in detail here, and the last is the agent core, which defines all the models, the reasoning, and any instructions that are associated with it. So what we have here is a movie agent that's going to use APIs to get information. So it's going to use the OMDb API in a couple of ways. It can use the API to get information about a specific movie. It can also use the API to search broadly for movies matching a search string. It's going to use Wikipedia API to get like more detailed information about plots and stuff from Wikipedia. We could alternatively have connected it to search as well to get any search results. It's going to use memory heavily so that it's a conversational agent, so it can rely on what was said before and use that. And then the agent core is going to be a Groq based language model. We can define an agent persona. I've simply called it like witty and helpful agent. We can also define do's and don'ts of what it should or should not do. And so the agent is a sum of all of these. It's gonna ping the APIs, get information. It's gonna analyze the information, look at its memory, look at the inherent knowledge in it, and looking at all of this, it's gonna respond. So what we're gonna do here is to go through how we build an agent like this. I recently launched a Udemy course that goes into building agents. Like it goes into the background of what are agents, what are their components, and then it covers each of these in more detail. So if you are interested in going into depth on tools, how to build tools, memory, different types of memory, planning, and then build more complex agents, please check out the tool here. I'll include the link in the descriptions. This is what the course looks like. It's called Hands-on Building Intelligent Agents with LLMs, and it covers basically things in 4 units. The first is just kind of an intro to agents, and then it talks about the different components in more detail. So it talks about tools, memory, and then planning, and then finally it brings it all together to cover a bunch of more complex agents that do more reasoning and loops and stuff. The course is meant to be very hands-on, so there's a lot of notebooks here that are code heavy. So I hope that like this video will inspire you to go for that. Okay, so I'll now go into how I built out this agent, and you can follow along on the code. Okay, let's go through the code here. I have put the code on GitHub and I'm shared the link to that, so you can certainly go and look at that too. Okay, the very first thing is to build the tools that this agent will use. And we're going to use OMDb API to be able to pull information. If you have never used the API before, you can log into OMDb API and then you can go to API key and you can get an API key here with a free 1,000 hits daily limit. So I encourage you to do that so you have your API key when you're starting this. Then as you go into the code, the very first thing you can do is to kind of create an environment file that would look something like this. So you can just put in your Groq, you put your OMDb API key. Similarly, you can go to Groq website, sign up for an API key there. That's also free to use for now, and then put that here, and that'll give you like the two things that you need to run the agent. Okay, so the first step I did was to look through the OMDb API documentation to figure out different ways to use the API. So I figured out that there's kind of the easiest way is to just basically import OMDb. You set your API key as default, and once you do that, okay, let me just load my API key here. Okay, and then I need to define that here for it, and then I have set it up here. Okay, there's basically two different methods here that are very useful. One is a get method that allows you to give the title of anything, and then it gives you back like the full details about that thing. So if I say True Grit, it's gonna give me information about actors, awards, country, director, ratings, plot, all of that stuff, and as well as the year, the writer. So this is information that can be used quite like, it's very useful to like get information details about any movie that a user is asking about. The other endpoint that's here is called the search movie endpoint, and this can be used to just broadly search for anything that matches a search string. So for example, if I put my search string as Naruto Shippuden, it's gonna hopefully go in and give me all movies that match that. And yes, it did that. So it gives me the title of the different movies that were released, the year, date, and stuff. And I think that you can now see how these two can be combined. You can first search for something loosely, and then once you have the title, you can put the title and the year here and then get more detailed information. So these are the two different endpoints from this OMDb API that are quite useful. The next thing that we're going to do is to build these as tools so our agent can use them. So I'll go through the code for that now. If you so the easiest way to kind of do this is through LangChain. LangChain makes it easy to create tools, and that's what we're going to do here. We're going to use the tool decorator here. We're going to define a class called OMDb, and we're going to define a tool decorator and write two functions. One is going to be get information function. The other is going to be search. The search are divided into two things, search movie and search series, because there were different methods in OMDb to do both. When you create a tool, you have to take care of a few things. You have to give the tool a name, a good name that the model will use to decide whether it wants to call the tool or not. And then you need to give it a description. So what I'm doing here as part of description is also sharing information on how to call the tool. So for example, I want to get movie info by title, but optionally I can also specify a year. So what I told the model is if the movie looks like True Grit, then and there's space, represent the space by this sign, %20. And if there is a year, represent that by pipe. So this is the data format it needs to send to me for me to search True Grit from 1969. So I did this because I found that the LangChain tools work the best when you have a single input in it. And if you do want to have the model pass you multiple things, you can pipe separate them. And so then once I get this information, I can parse out the title and optionally the year, and then call my OMDb API get method to get the results. So this is how you can just kind of, if you generally have a function, then you can use that to build a custom tool. and you can then pass this custom tool to a language model. So that's the general concept here. And similarly, I can write tools for search movie or search series using the search function. Essentially, I need to be very careful about the description of the tool that I specify here, as well as the name, because that's what the model is going to use heavily to decide when to call the tool, and then also give it the parameters that allow the tool to run correctly. I've covered a lot here quickly in the interest of time, but just sort of tools and tool usage and getting good tool results is a topic in itself. And if you're interested in learning, please check out my course. Okay, so now that we have the tool usage defined, the next step would be to define the agent. So let's do that. Okay, so I wrote like an agent in a notebook here, which makes it kind of easy to test. But at the end, we'll build a Streamlit app too, after which this code will be copied to a Python file. So to build the agent, the first step would be to load up all the keys that you need. The main key that you need here is the Groq API key. If you do want to check things in LangChain, then optionally you can import all of this stuff that will allow you to run things in LangChain as well. The first thing that we're going to do is to test out the tools that we built to make sure that they're kind of working correctly. So I'm going to use the tools defined in OMDb tools with those class to give a name to all these tools. So I have 4 tools here. I have an information tool to get information, and I have 2 tools for searching for movies and series. And then finally, I created a Wikipedia tool so that any specific information that these tools don't have can also be searched that way. Okay, so for the first tool, you can use the .name and .description to print the tool's name and description and check that it works. And then I'm going to ask for information, a Harry Potter movie released in 2001. I'm going to call this tool. And as expected, it does work quite well. It basically gives me information on the very first movie that was released. It gives me plot and rating and all of that stuff. Okay, then I'm going to use just quickly test the search movie tool. And here the IDSS is going to do a broad search. So I'm going to search for Naruto, and it's pulling everything related to Naruto. So this gives me confidence that the tools are working fine. And very quickly got the code here to test the Wikipedia tool as well, which seems to be working fine as well. So the idea that we have here broadly is that, let's go through our diagram again. We will send the user message to user will reach out to the agent. The agent is going to reach out, decide which tools it wants to call, then call the tools with the correct parameter, get the results back, and then it's going to use those results to either make another tool call or go back to the user with the response. And the response shouldn't really be the tool output. It should basically use the tool output to compose the response that is valuable to the downstream user. So we now need to write the core logic of this agent. Again, I found that the easiest way to build out custom agents like these is to do this through LangChain. And I'll go through the steps for that. So the first is to define the system prompt for the agent. In the system prompt, I've kind of followed a few rules. So firstly, I've just kind of defined like what the goal is. So I've said that you're a helpful assistant who helps users get information about movie and TV series. I very quickly introduce all the tools that are available. So the model also has information about these tools. And then I've also mentioned that, okay, you can also combine these tools, right? Like, for example, if you want to search about the very first Harry Potter movie, you need to use the search movie tool to get all of the movies, and then the info tool to get information on the one specific movie that's the first one that was released. And then I've defined some do's and don'ts. So defined its personality to be witty and smart, and it wants to keep the conversation lively. And then I've also sort of told him that, hey, I prefer that you use tools, right? You don't need to respond from your own memory, and tools are likely to be more accurate. But if you didn't find any valid response in a tool, or if you don't know how to use the tool or whatever, then you can certainly use your own memory. So this is sort of like a blueprint that you can follow for building any agent connected to APIs, right? You need to convert those APIs into tools, and then you need to define a system prompt that tells the model what those tools are, when to use them, and it also kind of defines a roadmap for whether you only want to use the tool or you want to back up to using its own memory if the tool usage doesn't work. Okay, awesome. So the input here is going to be the immediate user input as well as the prior chat history. And then we're gonna essentially like the agent here is sort of a combination of two things: the prompt, which is what we defined here, as well as the model. So we instantiate a chat Groq model, and we're going to use the Llama 370B here. And so the agent is essentially a chain of the prompt and the model. One interesting piece I want to highlight here is that you bind tools to the model, because these tools, when you do bind tools, then if you remember, we had set up all the description for our tools, the names and the descriptions, those get automatically attached to the prompt. So the model, again, makes it easier for the model to know what all tools are there. Okay, so at this point, let's just test out what we've done so far. So we have, just to kind of review, firstly, we've written a prompt, we've defined a model, and we made a chain of both of those things, and we're going to test out the chain. So if I say, tell me about the very first Harry Potter movie, I'm going to see what the assistant does. And I'm going to check specifically what tool calls it does. And I see that it did a search movie tool with the arguments Harry Potter. And so that sounds correct. Like that's what I would want it to do. And then I say I need information on the movie called Inception, including its tomato meter rating. So since it already knows the name of the movie, the ideal tool would be movie info by title. And it does that, it calls that. And then if I just say, let me just do some crappy thing. Tell me about the city of Tokyo. Okay. So ideally, I would have used Wikipedia here, but let's see what happens. Yeah, okay. Yes. So it does Wikipedia's query for Tokyo. So at this point, like based on this testing, we know that we have a model the LLM that works quite well. We have the tools defined into the model, and the model also knows how to call the tools with the right parameters. So the next piece that it's kind of remaining here is that once the model does come back to you with the with kind of output that says, hey, I want to use this function with these parameters, then the remaining thing is to basically use or call that function through that argument, get the results, and pass that back to the model so it can move further. So LangChain kind of makes this easier. Like, I mean, you can do this basically with or without LangChain. You can pass the message, call the relevant function, give the message back into the model. But I found that LangChain does help doing this. They've built something called an agent executor here. And what the agent executor does is it actually executes the tools. So it you pass to the agent the assistant that you created. You pass to the executor the assistant as well as the tools, and it helps you run the tools. And that actually makes the whole thing smooth. So basically, I'll run the tools at the background, I'll pass that to the model, and then the model will either respond back or it can again run the tool again. And so this makes it like it kind of hides that in the background so you don't have to do it. But so it's easier to do, but it's good to know how it works. So the last piece that we're going to do is going to tie all of this together. So I created a class called chatbot. So what you have here is the same system message that we used. Now that we're going to move from like just kind of instruction following to a chatbot, we also need to define memory, and memory is going to hold the last conversations, which makes it like more conversation driven things. We're going to define all the tools that we had before. So now let me highlight the differences here. So because I want to use the tool executor, I defined a agent scratchpad because that allows the model to have history of what tools it used, what output it got. And the rest of the stuff is the same. So you have the system prompt, you have the chat history, which allows for the memory to be there. You have the user input, and then you have the agent scratchpad. So what you do here is you first create an agent that has the model, the tools, and the prompt all tied together. And then you create an agent executor. The executor is then able to run the tools. So I think these two are different things. One is to define the agent. If you just leave at defining the agent, then you have to run the tools yourself. If you're able to define the agent executor, then the tools get run together as well. And then finally, you use the runnable with message history module in LangChain to tie all of these together. So you have the agent executor, you have the memory in it as well. And so it makes the whole loop go well. So I know this is a lot to take in. So again, like, want to encourage you to check out the course if you want to learn how to build these things like block by block. Okay, so now that everything is ready, I did put return intermediate steps as true so we can check the output as it runs. The last piece that's remaining is to actually call this movie bot and then run about them, and then we can see what it does under the hood. So this movie bot, I'm gonna run on the same query. Tell me about the movie Inception. So here's what it does, right? Let's go through it. It first says, I want to call this tool with this data. And then it actually executes the tool itself, and the tool gives it this information here. And then in green, it says, I've got all the information, and then it goes back. This is the response it gives back to the customer here by using the information it got from the tool to respond back. So you can get it to sort of give you out the full chain too, but that's the idea. So that's what we really want, right? When we're chatting with an API, we want it to figure out which API to use and how to use it, and then get the output from that kind of the tool or the API, and then compose a message here. So this is sort of like a perfect response here. Okay, so tell me about all the Naruto Shippuden movies. Okay, I'm gonna try this. I found that this one works sometimes doesn't work. Okay, so what it did here is it responded itself directly. I would have ideally used it to go use the search tool to get information, because that's probably going to be more recent, right? But it does, I think, respond correctly, and these are all the movies that are there. So it does that. Let me try one more chain. Okay, tell me about all the True Grit movies. Okay, so this one as well, it was able to respond by its own message. So I think this is where I find that if you want the model to follow instructions more, if you have more instructions or more tool use, you kind of sometimes need a model that's capable of more instruction following. And I think that this Llama 70B is sometimes follows and sometimes doesn't follow instructions. So that's something you have to watch out for, is how you structure it to follow instructions more. Let me actually try one change here. Let me just highlight this as very important. So I made a small hacky change. I made it very important for it to follow the tool usage instead of memory. And I found that made some difference. So when I run this, tell me about the movie Inception, it first used this tool to get information, and then it used Wikipedia to get even more information. So now it's able to do like the two tool usage instead of a single one to get more details and then answer more accurately. But I still found that this model wasn't perfect at always following tool usage. So that's something to look out for. If you are gonna put this in production, do something similar in production, it'll be good to test out models like GPT 3.5 Turbo or GPT 4o, because they may be, I found that they're better at instruction following than some of these models, these open source models. Okay, so this tells you how, so I think at this point we've kind of covered the main things that I did want to. So I've showed you how to how to convert, how to first of all look for API documentation, get the different methods, then write them as tools, how to connect memory, and then how to write your system prompt that gives you the do's and don'ts and the personality, as well as create a Groq-based model. The last piece I want to show here is how you can convert this into a Streamlit chatbot. So I did two things here. So firstly, I took all the code that I had in the class here for chatbot, and I moved that to a file by itself, call that agent.py, but it has essentially the same code that runs basically the agent has all the tools defined to it and the executor to execute the tools. And then I'm going to create a fairly simple and standard Streamlit chat interface. And what I need to do here is that I created this movie agent class here. And then what I do here is that once I get the user prompt, I do the run method in this class to get the response, and I display the response back. So this is how I ended up building this Streamlit app that polls the API or the Wikipedia, gets the information, writes it out, and also has memory to sort of to talk to me, like to do more conversational type answering. Awesome. I mean, that's all I had for today. If you have questions or comments, let me know. I hope you subscribe to the channel and check out the links for information on how to get the code. You can also post a link for the Streamlit app there, and then finally the link to the course as well. Thank you.